As shown, a is a constant that is not equal to 0. Alpha and beta are the roots of this equation, x squared plus 2x plus a equals to 0. 1 over alpha squared plus 1 over beta squared equals to 1 over 4. Find the value of a.
Pause the video now if you wish to solve it. Keep watching the video once ready.
This information, we know that alpha plus beta equals to -2, alpha beta equals to a. Then 1 over alpha squared plus 1 over beta squared will equals to alpha squared plus beta squared over alpha squared beta squared. This is equals to alpha plus beta squared minus 2 alpha beta, and this is alpha beta squared. Therefore, this is 1 over 4, and this is equals to -2 squared, which is a 4, minus 2a over a squared. And this gives us a squared equals to 16 minus 8a. So a squared plus 8a minus 16 equals to 0. So solve this, complete the square, we get this equation. So I continue here. From here, a plus 4 equals to plus minus square root of 32 equals to plus minus 4 square root of 2, and a therefore equals to -4 plus minus 4 square root of 2. And that is our answer here. So as shown in this question, this is an equation x minus 1, x minus 2, x minus 3, x minus 4 equals to 3. We are asked to find the product of all real roots. We need only the product of all real roots.
Pause the video now if you wish to solve it. Keep watching the video once ready.
So we can start from combining the factors. We will get x squared minus 5x plus 4. And combine the second and third factors, we will have x squared minus 5x plus 6 equals to 3. We may let u to be equal to x squared minus 5x. So this will equal to u plus 4, u plus 6 equals to 3. Expanded, u squared plus 10u plus 24 minus 3 plus 21 equals to 0. So u plus 3, u plus 7 equals to 0, u equals to -3, or u equals to -7. If u equals to -3, u equals to x squared minus 5x. u equals to -3 will imply that x squared minus 5x equals to -3, x squared minus 5x plus 3 equals to 0. Note that the discriminant is b squared minus 4ac. In this case, it is -5 squared minus 4ac. That is 25 minus 12, and it is 13, and it's positive. This means that the quadratic equation has two distinct roots. On the other hand, if u equals to -7, so from here, x squared minus 5x plus 7 equals to 0, the discriminant equals to b squared minus 4ac equals to -5 squared minus 4a and c, that is 25 minus 28, that is -3, and it is a negative value. Since the discriminant is negative, it means that this quadratic equation has no real roots. So the real roots only come from this part, right? So we want only the product of all real roots, and it can only come from this part, and therefore the product of all real roots will be the product of all real roots in this quadratic equation, and that is C over A, that is equals to 3, and that is the answer. For this question, K is a constant, and this quadratic equation has two real roots, one of which is one more than twice of the other. Find all possible values of K.
Pause the video now if you wish to solve it. Keep watching the video once ready.
Now that is important here. One of which is one more than twice of the other. Let's say one is alpha, the other one will be 2 alpha plus 1. So let alpha and 2 alpha plus 1 be the roots. So the sum of roots will be equal to negative b over a, negative b over a. And the product of roots will be equal to c over a, c over a. From this second equation, 2 alpha squared plus alpha minus 171 equals to 0. Factorize it, 2 alpha plus 19, alpha minus 9 equals to 0. So alpha equals to negative 19 over 2, or alpha equals to 9. From the first equation, K equals to negative 2, 3 alpha plus 1. If alpha equals to negative 19 over 2, K will equal to negative 2, 3 of negative 19 over 2 plus 1, 55. If alpha equals to 9, K is equals to negative 2, 3 alpha plus 1, negative 56. We still need to check whether we can accept these two solutions. And it says that there are two real roots. If the equation has two real roots, the discriminant equals to b squared minus 4ac has to be greater than or equal to 0. So in this case, it is equal to k squared minus 4a and c. This is 2736. And we can check that the k squared here is 3025, and the k squared here is more than 3025. Each of this is greater than 2736, and therefore these two are the possible value of k.